So what we're going to be talking about in this session is a lot about what containers can do with your microservices. We're going to talk about that and the new advances that are happening in that category around something called Istio. Talk about microservices from that perspective. And we're going to also talk about the serverless architecture that's going to be booming within our industry for the next several years. One thing I'm curious about, how many people here have already done, if you don't mind this show of hands thing, have already done some microservices? Fantastic. If you notice, that was almost all of you, or the majority of you. So every audience I go speak to about microservices, even if I'm doing an intro to microservices presentation, they've already done microservices. So it's one of those things where everybody's doing it, okay? Now, we'll dive into this in a different presentation later today, but I'm curious, for those people doing microservices, do you have kind of a flat structure of your microservices, meaning let's say the mobile application or the business-to-business API is interacting with several microservices in kind of a flat structure? Or do you actually have a network graph of microservices, more like Netflix? How many people are more like Netflix and have this massive graph of microservices? 2, 3? Okay. And for the rest of you doing microservices, are you more that flat structure where it's more just a series of APIs deployed independently, but a series of APIs and the mobile application or the business-to-business application interacts with? Is that more your style? And are you using API gateway with that technology? Okay. Which one are you using?
We have our own internally developed API. Initially, we were using an external product. Now we are using internally developed.
Okay. Written in C++ or Java, or what is it, Nginx based? Okay. There's a million ways to build one of those things these days. Very popular option actually is the Vertex technology that we support. You know, that reactive architecture, it's basically thread pull less because it's a reactive architecture. That people love using that as an API gateway solution as an example. Okay. So one of the things you'll see later today when we have a deep dive session called Java Developer's Journey to Kubernetes. It's about a 2-hour session. We'll talk more about the microservices patterns and architectures, and we'll do an even deeper dive into Istio at that point also. Then we'll touch on it here to kind of give you a taste of what's going on in the Istio world, but there's a ton of sessions you can dive into this week. We're very much focused on Istio here. You'll hear about it here. You'll hear about it in our booth. There was actually a session I think, running right now at Christian Posta out of our booth in the dev zone. We have a Istio hands-on workshop tomorrow around 11, I think it is. I have it listed here in the slides. And so you'll get a chance, if you really want to get into Istio, you'll be able to get all in it and touch it yourself. And I'll have several links in this presentation where you can actually go offline and try Istio on your own computers. Now, here's the cool part about Istio. Well, actually, let me ask another question. How many people here are already OpenShift folks using OpenShift? All right, fantastic. That's a good percentage of you. Anybody here just straight Kubernetes, no OpenShift? Okay, really good, very good, fantastic. And so if you guys are already in the container orchestration universe, the way to think about Istio is that it layers on top of Kubernetes. And so you'll see that right away, right? There's an additional set of pods that you deploy, but a very specialized thing called a sidecar container that really makes the magic happen. And it's essentially just intercepting all the traffic in and out of the pod. We'll talk more about that in this session. But that's how the magic works. So if you think of like a Wireshark or something of that nature, you know, it's a man-in-the-middle attack, but you've brought it on yourself, okay? Because you're basically going to intercept all the network packets. So it's really cool technology, and if you're really interested in microservices, at least an advanced topology of microservices, it becomes incredibly useful, incredibly powerful, and that's why it was invented. So we're going to talk about that also. So we got a lot of fun stuff to touch on today. How many people here have already tried hands-on with serverless architecture or function as a service? Anyone? All right, and what function as a service engine have you tried? Amazon Lambda, that was the first that became popular, so certainly a lot of Amazon Lambda. Anyone else try something? OpenWhisk, okay. I have my OpenWhisk running right now. And actually, we're going to have a little OpenWhisk deep dive presentation in the booth right after this. I got to jog from here to there. And we have a hands-on lab with OpenWhisk in the booth. So if you haven't tried OpenWhisk before and you want to get your hands on it, we're going to let you do that. Yes, ma'am? What's that? It's in our booth. I know that sounds kind of strange, but we actually have a little theater set up there, and we have a bunch of laptops. And I'm going to run straight from here to there. And then my colleague, Kamesh, and I are going to do a little presentation on OpenWhisk. We don't have a formal lab with OpenWhisk. We just couldn't quite get that ready in time. But you will see us talk about it a lot in our booth, because we have a hands-on lab for it. We also have a deep dive session on Thursday for OpenWhisk. And if you come to the keynote at 8 o'clock Thursday morning, you're going to see OpenWhisk running at tremendous scale, doing some really cool things. We have hundreds of cores running OpenWhisk at this point for our Thursday demo. And I can tell you guys a little bit about that also. You guys will be in the know. How about that? In the know. Okay, we've still got 5 minutes. Do you have any questions for me? Anything you would like to get out of this session that you were thinking, oh, I read the description. I don't know what that crazy person's going to talk about. But yes, sir.
I would like to understand if OpenWhisk offers any advantages over AWS Lambda or Others.
Okay. I think we can definitely touch on that. That's a very good question. OpenWhisk over Amazon Lambda. At least you'll hear what the vision and desires are. And I think you'll see something today, and you'll definitely see something on Thursday. Yeah, we're going to try to make that point very positive. We're going to prove that. At least we're going to try. I've been working really hard on that point. What other things would you like to get out of this session? We have a large number of operations folks, which was fairly common on the Red Hat Summit side of things, right? That's often who comes to Summit. Anything that you guys would like to know more about? Because I'm on the development side, but from ops perspective, what would you like more? Yes, sir, in the back?
Anything on competition?
Known competition?
Anything on competition?
Competition with, okay, competitive what, between Red Hat and VMware, or whom?
Well, we're talking about OpenShift, right? So what about Pivotal?
Ah, Pivotal. Yeah, are you familiar with Pivotal Cloud Foundry and PKS? Yeah. So they also have PFS they announced, which is their function as a service that is going to be based on Project Riff. So I have spent a lot of time looking at Pivotal in particular. This isn't really a competitive analysis kind of presentation, but we can certainly talk about that either offline or a little bit later. I have friends who work over at Pivotal, so I've been following them for quite some time. I'm actually one of the original JBoss folks that came through the acquisition, and several folks went to work there after the acquisition. So there's ex-JBoss people, now Spring people, if you will, and Pivotal people. But at this point, the easiest way to think of it, to summarize it, OpenShift, of course, is our distribution of Kubernetes. It is how we support it. We don't necessarily offer you the upstream directly, because there's a ton of enterprise features that we add on top of Kubernetes to make it ready for consumption by the average enterprise. And these are significant. For instance, the original Kubernetes came with no form of RBAC or security at all. So it was just kind of wide open. Well, we knew that when we put this in an actual data center, that would not hold. So we actually were the ones who contributed all the RBAC and security capabilities. So you see that a lot from us, where we're making it enterprise ready. So that's probably the biggest, greatest distinction between us and the other Kubernetes players, is we're always basically optimizing OpenShift for that enterprise, big ops, big use case at a big organization. That's probably the easiest way to summarize it. Okay? Well, I'll tell you what. We've got a bit of a crowd. Have they let everyone on the wait list in too? Do you know? I know they're being kind of sticklers about getting your badge scanned to get in here with the RFID tag. I've always thought it'd be fun. You know, I used to do a lot of IoT stuff. I wanted to basically make fake badges with RFID tags and see what we could do with that. Does anyone here remember the demo we did a few years ago? It was a keynote demo where we actually gave people Bluetooth beacons. We tracked you all around the conference. Was anyone here for that? Oh, that was awesome, right? We had little Bluetooth beacons that run on a coin cell battery. It's a CR2032, which is good if at high a burst rate for probably 3 days. But we had over 7 million transactions we collected from those Bluetooth beacons, and all we did was hang Raspberry Pis in all the meeting rooms, and we were able to triangulate everyone's position throughout the day. So we actually then, during our keynote, the keynote was later in the day then, we actually showed everyone's movement from breakfast to the breakouts all throughout the day, and then all arriving at the keynote at that moment. It was a totally awesome presentation, but boy, did we have to kill ourselves for that. I mean, myself and other people were running around and trying to reboot Raspberry Pis in rooms and things like that. When the Wi-Fi got knocked out, because that's often what happens, we had to switch to Ethernet, had to find a cable. Always a lot of fun. In that specific case, we used ActiveMQ to gather all the transactions, and we used Apache Spark to do the analytics, the triangulation of which Pi are you closest to. Because any given beacon would be picked up by 2 or 3 Raspberry Pis, and you can use the signal strength to basically measure which one is the closest to. And they would have to just make a logical guess. You're in this room and not that room. We even went so far as to actually wrap some of them with aluminum foil to try to dumb them down. You think I'm kidding, but no, we tried. Okay. Well, let's go ahead and dive into this content here. There's a link at the bottom of the slide that you want to have because the next slide has other links and the next slide has other links. You're going to see links all throughout this presentation and someone's going to say, wait, can I have the slides? Go to that link. You have the slides right now on your phone, on your tablet, on your PC, on your Linux machine. It's a Google slide deck. It's live. If I have to make changes to it later, you'll see me making changes to it. Okay? And you can basically download it as a PPTX if that's what you want and take it on your own. You can fork it and make a PDF out of it. So that link at the bottom is super critical. So just make note of that one. Because we have a lot of cool stuff here to show you. Okay? Like all these links. So if there's something that you missed in the presentation, you're like, I didn't quite hear that correctly, here's where all the content is. We already have a great free O'Reilly book for you that talks about microservices architecture and walks you through things like Spring Boot and Wildfly Swarm and also Drop Wizard, just to get started with that traditional style of microservices architecture. We also have reactive microservices based on Vertex. Completely different programming models, but two very valid, cool ways to build microservices running in containers, running those containers on Kubernetes as an example. Those are free ebooks. Also in the middle there, you'll see we have a MSA instructions. That's a huge deep dive. It's just a GitHub page, right? You go there, it's a huge deep dive in how to build microservices architectures, showing you different patterns, showing you different programming models, and also walking you through things like SSO, CI/CD, you know, how to build a pipeline, how to do things like security. It's really an awesome presentation there. We also have another slide deck where we did a deep dive and a video training. I think I recorded close to 3 hours of video training that you can dive into this topic. And so there's just a ton of great stuff there. Also, what we're more here to talk about today is the advanced microservices architecture around Istio and service mesh technology. And I mentioned that we also have OpenWhisk that we're going to be talking about today, and serverless architecture. You can see there's the GitHub tutorials and real live things where you can start touching and working on right now. In other words, you can go to learn.openshift.com and launch Istio and start playing with it right this second on your device. Okay, because it basically runs the whole VM in the cloud for you, and you can start taking advantage of it right away and learning the technology. We've done that also for OpenWhisk. And if you come by our booth in a little while, like we're going to be running an OpenWhisk session right after this one, and we're going to be using those same tutorials and walking people through it, letting people get their first chance to try either Istio or OpenWhisk. Okay? Anybody here already used Istio yet? Okay, just a couple folks. And then I know we had one gentleman said he had done OpenWhisk. Another gentleman said he had done Amazon Lambda. So we're going to get it all into that right now. You guys cool with that? If I seem kind of hyperactive, by the way, it's just how I am. And people think I talk too fast, but I'm originally from Hawaii, and then also I'm from Alabama. And then I was back in Hawaii for high school, and then back in Alabama for college. And I'm really the fastest talking Hawaiian Alabamian you'll ever meet. And I don't know how to address that, but we'll try to get through it. These are some other sessions. I promised lots of links, right? So one reason we wanted to do this session first, directly after the opening keynote, was so you guys could know what your trail map might be if you want to get more information about these key topics. These are some sessions I think are very powerful. You see the top one there is the hands-on session with OpenWhisk, starting at 11:30. You've got to hustle down there. You also see a great Istio session there, listed at 11:45. Also, data streaming with Kafka. So if you're interested in Kafka and streaming use cases, I recommend that one. Myself and Raphael come back to 206. Is this 206? 207. So next door then, we'll come back and that's our deep dive. We do 2 hours of basically everything you hear here, but we'll go deeper and further and show you a lot more cool demos. At that point, I should get all the demos up and running. Machine learning, fantastic session there if you're interested in machine learning and AI. And you're going to see a lot of machine learning and AI in our Thursday keynote demo, so be prepared for that one. There's a hands-on session for Istio. That's a real nice lab. You're going to sit down. You're going to get a full document on how to run all these things, how to install it, how to use it, what you might do with it. We'll talk a little bit about it in the session, but you can really get hands-on with it there. Another great session with our security team, because one of the things Istio provides, in addition to providing that service mesh, it allows you to secure your microservices kind of at scale. Okay? And so we'll hear more about that in a second. CQRS and event sourcing, another very powerful topic. For those folks who are kind of hardcore, you're going to CQRS and event sourcing architecture. Is there anyone here using CQRS or event sourcing yet? Yeah, this gentleman here? Not too many. It's a fairly advanced topic, and so if you're interested in that, I recommend checking that out. It'll be just good for mind expansion. Or you might just be completely tired and at that point not want to hear more. Okay? And then Thursday in the afternoon, we do have Brendan McAdams, he's from our OpenWhisk core team, and he's going to be here to talk about function as a service. So I'll put these links up again a little bit later in the presentation. We've got to keep moving fast now. So let's go ahead and dive in. This is a critical book, because if you noticed, a lot of hands went up earlier when I said how many people are doing microservices. Everybody's doing microservices, and therefore you've already encountered this problem. What do I do with my monolithic database in a microservices architecture? This is the book for you. Okay? Edson Yanaga on my team was able to write this book last year, putting lots of cool tips and techniques on how do you deal with a monolithic database, how do you manage migrations in a database, how do you basically deal with the fact you've got a million little microservices database, et cetera, et cetera, et cetera. Lots of great tips there. I highly recommend it. It's a free ebook. Also, we just published this book. So Christian Post and I worked on this book recently, another free ebook to get you started with Istio. So the Istio tutorial I mentioned earlier and the hands-on Istio lab follows the same principles as you see here. We just reuse the materials, but a free ebook. And we have copies of these books, by the way, down in the dev zone. You can run down there. Doug will be down there giving them away, right? Yeah. We have actually the physical copies of the books. I highly recommend you coming and get one. We also have book signings scheduled throughout the week. I don't know what that schedule is. Okay, let's kind of get into this now. We cannot solve our problems with the same thing we used when we created them. I love this quote. And if you've been around enterprise IT long enough, and I really have been in programming for 30 years, we've created lots of problems for ourselves. We've created lots of legacy for ourselves. I know I have. There's still code that I wrote that probably runs on Air Force bases to this day, literally. And I feel bad for those people. Wow. You know, so we have to be thinking about how we modernize our applications and how we evolve over time. And if we can, architecturally build flexibility and agility into the technology up front, we will be better off, even if it's someone else's problem in the future. But if you are a programmer, I know you've had this moment. When you opened up that code base you inherited from some other person, you're like, what's that person thinking? You know, what is this crap? But you don't know the constraints they were under when they had to build it. Their boss may have gave them 2 hours to write the whole system. Or you just have this weekend. Or you can only use Java 3 on WebSphere. Okay? I love that particular constraint because I've had that one and you're like, I just want to kill myself. You know? So there's all these challenges that you don't know what they had. And this is what modern software development looks like, or modern enterprise IT delivery looks like. Okay? This is the fundamental problem we have to address within all of IT, and we use DevOps and microservices and things like that to help address this. But is this what software delivery looks like in your organization? A huge number of people trying to move an amorphous blob up a hill, trying to get that rock up a hill, but in this case it's an amorphous blob. And you're probably thinking, yeah, it looks a little bit chaotic like that. And then you're thinking, but there's this person. And if you're a developer, you're thinking, that's the ops person, right? And I got to tell you, developers, we got to stop being so arrogant. We know that's not the ops person. That's the DBA. Okay? And then you probably think, well, who's this person? Well, we know that's our enterprise architect, you know, trying to ride herd on the blob kind of thing. And then actually, this is our ops person down here, being crushed under the weight of this nasty thing that we've created. And so that is the problem we have in modern enterprise software development in any large organization. We have to stop doing this to ourselves, because as soon as we get up the first hill, we did that 9 months, we got to do it again in 9 months. We got to do it again in 9 months, or 6 months, or 3 months. Whatever your deployment cycle is for that application, you do it every so many months. In one case with one government organization I was talking to recently, it was every 24 months. Yes, they hated it, because everything in the world had to fit into one 24-month deployment. Because if you only get deployed once every 24 months, you try to throw everything in the kitchen sink in there, which makes testing impossible, which means the cycle time gets even longer, and everybody's miserable in the process. So software development needs to look more like this, where we actually have a cohesive piece of software, a nice round block at least, where we've actually shaved off the rough edges, and we're all pushing in the same direction, a small team with a nice, concise way to deliver it. Okay, so this is kind of my preaching on DevOps in particular. So one thing you have to ask yourself, and this is actually critical, and I want you guys to think about this for a second. Do you belong to that first question? Do custom apps and APIs, are they a key strategic advantage to your organizational success? Do you have to serve customers better? Do you have to serve citizens better? I once had a conversation with a relatively large pure, well, in this case, it was, let's just call it big government, for lack of a better term. And it wasn't quite big government, but they had no competition. They had no need to go fast. And I said, well, actually, you do have a need to go faster, because you actually have real citizens, real humans that are fundamentally impacted by your inability to deliver IT services to them every day of the week. And it was just a different way for them to think. So yes, they have no competition, they have no problem making money or whatever they have to do, but there are people at the other end of that equation who are waiting for that feature to work properly. In this case, it was actually more related to healthcare. And guess what? People were waiting on healthcare services because of this system that they could not deliver on time. So think about that top bullet. Or your organization might think more about this bottom bullet here. Do you regard IT as a cost center that must be streamlined? And these are fundamentally different philosophies. I personally love living in the first world. I want the stuff I build, the people I work with, the teams that we create to build awesome stuff to make our users even more awesome. That's what we're about. That's what we're about at Red Hat, okay, fundamentally. I know sometimes we deliver something, you're like, what were you thinking? I know, I appreciate that. I see how the sausage is made. But at the end of the day, we always talk about this inside the company. We have to deliver things to make all of you, as our customers and users, even more awesome. And if we fail to do so, you won't be customers and users for long. That's how it works. We have to think more like number one. But in our many cases, people think like number two. But think about that for a second, okay? This is a great quote from a fellow, you might know this one. Okay, our ancestors called it magic, but you can call it computer science. The land I come from, they're one and the same. That's one of my favorite quotes also. Now here's our monolithic application. For those of us who have delivered applications before, we knew exactly what that monolithic application looked like. We knew what it felt like. We knew what was involved with it. But we did this thing over the last couple of years. We said, no, we got to break up that monolith. We got to basically make it little piece parts inside that thing. And we've started to lose sight of our monolithic application. It's still a big system. It's still a system of pieces that have to work together. But what has happened is we've called these things microservices, and then we've started to distribute them around a network, into a mesh. And that's why I asked the question earlier, how many people have a flat structure where all these things actually live on the left side of this chart versus a graph structure, a network of services? It's because when you get into this architecture, a very sophisticated microservices architecture, where things get interesting. If you have a flat structure, you actually don't have to have a Kubernetes or an OpenShift to manage that. You can kind of just get away with just running a bunch of VMs pretty easily and just ensuring that you orchestrate how those things pop up and go down. But if you get into this kind of architecture, you can't afford downtime in the middle of this mesh. One little bit of downtime here could fundamentally change everything about your system. So this is where things get very sophisticated. And we'll talk more about those things. And it's especially true if you have multiple databases like you see on this chart. Okay, there are also multiple points of entry. That's why something like an API gateway starts being advantageous to you. You know, how do we let people in and out? What, of course, of our schemas and what kind of things are we delivering to that user? In many cases, this is for our business-to-business partnerships and opening up those APIs so they can interact with us directly. We also now have functions. So this is where it gets totally weird. You can actually not have microservices in some places and have functions, event-driven functions. We're going to talk more about that, and that's where OpenWhisk comes in. Okay, let's keep going here. Another great quote. You know this person with the pointy ears? Change is the essential process of all existence. That's a good one. And if you're a Star Trek fan, you know, you get it. Okay? Now here's the fundamental thing you should be thinking about of microservices versus functions. I mentioned that you can have functions now in this architecture. Your microservices are where you want complete control. You control it. You, the developer, you, the operator, you have control. Okay? That's very critical. You have control of how long this process lives. If you decide to kill -9 it, you can, because you own it. You basically know the programming model for this already. It's often very synchronous in its architecture. If you think of all we've done with LAMP many years ago, right? Linux, Apache, MySQL, PHP, or Python. Very synchronous architecture for delivering web pages and web architecture. Maybe you've done Java, Java EE, Spring, Spring Boot. All these things are very standard ways of doing applications, building out an API, building out that application. So this is a very mature environment on the left. We've been doing it for 20 solid years now. I've been doing web applications since 1996. So we know how to do this. Get, put, post, and delete has not changed that much. You know, most people don't even know we have HTTP 2 at this point. We've been living off HTTP 1.1 from, I think it was 99, all this time. The architecture is very well known. In the case of serverless architecture, though, it is under cloud control, not your control. They determine the life cycle, when it starts and stops, not you. Okay? You got to think about that. And it's normally for a very short-lived process, and it has a fundamentally different programming model than the other side. I'll show you a little bit of the code so you can kind of see what it looks like. But it's an event-driven asynchronous architecture, and that does change the game. You have to factor that in. And you notice I said it's immature and a question mark. There's not much IDE integration. We're really not quite sure how we debug it yet. The tracing is not quite figured out yet. There's some startups that are working on it right now, startups that integrate directly with Amazon Lambda as an example. So you have to think about those things too. But I'll show you a little bit about it. And like I said, there's a deep dive session right after this one, as well as more sessions coming throughout the week. Okay? Now, this is a great quote that you have to think about from ThoughtWorks. I really have a lot of friends at ThoughtWorks. I love the stuff that they talk about there. But the way you have to be thinking about the new application architecture at this point is, do you want to build everything or do you want to buy it? It's always the buy versus build trade-off we've always had. And is there a product or service that you can just take advantage of versus recreate it yourself? This is important because I've been around long enough to see people build their own app servers, build their own message brokers, build their own container orchestrators. Some of you here have probably done it yourself, right? You know, my company, we have our own specialized MVC framework. Anybody here have that? It's like, no, you couldn't use struts or Spring MVC or any of the other 4,000 that are out there in open source. You had to build your own because we're special. Or better yet, you couldn't use any of the 15 awesome message brokers that are in open source. You had to build your own. This happens all the time. And you have to start thinking in terms of, can I just buy it, not build it? And that's the mindset you start getting into from a serverless architecture perspective. Because SaaS is what makes serverless serverless. Okay? Serverless by default is a misnomer. There's still servers out there. The question is, do you, on the development side, know about them or care about them? Or not? Okay? If the developer can ignore them, then it's serverless to them. That's how to think of it. All right, so it's all about the services in a serverless architecture. The first service I like to call your attention to is an API gateway as a service. I need HTTP in and HTTP out. I might want WebSocket in, WebSocket out. HTTP 1.1, HTTP 2, doesn't matter. You might need that service. You might need some form of SSO service. You know, some sort of secure sign-on, securing those things. I want a storage service. This is where I might have files that are being uploaded to me. I need a place to put them. The binary files, the insurance paperwork that's uploaded by my customer. I just actually did a home mortgage application, and all I did was upload files to these folks, right? And that's the whole operation was completely digital at this point. I was so shocked by that. Everything, even the signatures were all digital. I was really impressed. Cache as a service, database as a service, I consider these to be fundamental. Notifications and messaging as a service. How do you get connectivity in and out of that system? And of course, you can still have your microservices, just like we've always built them. It's just now we've integrated them with these software as a service. And then there are functions, the event-driven connective tissue that allows you to bridge the gaps between these other components of your system. So you buy some, you build some, and then you wire some together. This is how I believe the future architecture will be in the next several years. And if you are going to pay close attention, you're going to see this being demonstrated at great scale as of Thursday. We built a system on this architecture, and we're going to go for another big demo. Okay? And I need all of you there, 8 o'clock in the morning, Thursday. I know it's early, because I actually need a bunch of beta testers. You guys prepared for that? Okay, cool. I'll tell you what the URL is when you get there, but it's actually going to be a ton of fun, and we've gamified it, and I have to mention, just so you guys know, we have some really awesome prizes for people to make the top 10. Okay? So you guys are in the know now. All right. All of this, of course, is awesome. And actually, let me show you a demonstration of some of what we talked about here. I don't have my Istio demos running right now, only because it's so hard to kind of run everything simultaneously. But let's try this. I'm going to bring up my programming editor, hopefully. Come on. It's trying. Oh, Lord, this machine is slow. Let's see if we can get in here. And there we go. Here's what a Java function looks like. You know, we should, at this point, everyone should be pretty comfortable with microservices. But you can see a function looks a little bit different. It has a main, in the case of Java, it has a main method. We should be comfortable with a main, you know, it's standard Java SE stuff. And you can see it takes a static JSON object, or returns a static JSON object, and it has a JSON object input. JSON in, JSON out. A function is in and out. That's all it is. and you put your business logic in there to decide what to do with it. This is a very simple kind of hello world one. It just takes the inbound parameters, kind of displays them, showing you what's in that JSON blob. You notice JSON is a little bit funny to work with in Java land. Would you guys agree that it's a little bit odd looking there? Because it is, right? Java being a statically typed language, JSON being more JavaScript object notation, you have to get a little bit funny with it, and this uses the Google library for that. But this is an OpenWhisk function. You can build it, and you deploy it, and then you can invoke it through any number of event-driven ways. So this code I already have running. Let's see here. And I can kind of, let's look here. List. Okay. You can see I have a bunch of actions that actually come out of the blocks already running. This all, by the way, is running on OpenShift. So I have OpenShift running here in the background. Is this the one? Yeah, yep. You can see so all this OpenWhisk technology is running here as OpenShift pods. So this is important. Not only is the OpenWhisk architecture running as pods, running as containers inside of OpenShift or Kubernetes, but every function you deploy runs as a pod. Okay, so let me see if I can show you this. Let's see here. We want to label status in, not in. We want in. There we go. Active. Add. All right. Let's see if this works. It's a bit tricky. And I'm going to run that function. There we go. So the function comes to life, and the function goes away. Let's see how well that works. So you can actually, the nice thing about OpenWhisk, it's unlike Amazon Lambda, but you have control of the operational architecture. So the question you had earlier is what the differences are. One of the primary wins with using OpenWhisk, let's say on-prem or on your OpenShift, is you can decide that timing interval. You decide the limits. So by default, I think it's a 10 megabyte upload limit on Amazon Lambda. It's a 2-minute or the 5-minute execution time now. So it was 2, now it's 5. You have all these limits that Amazon imposes. In this case, your operations team is responsible for those limits. What is the life cycle of those functions? But you saw it kind of came and went. And this is kind of cool, because let me show you this. All right, so I'm just running that Java function. You can see it come and go. Okay, in this case, my machine is actually very busy, but you can see it come to life and go away. But let's do this. I'm going to back up one directory here. Let's see if we can get another code editor open. Yeah, how about the JavaScript version of this? Okay, let's see here. So right here with JavaScript, very similar to what we have with Java, it's basically doing the exact same thing. It's taking the parameters you provided through a JSON object, enumerating them, and of course returning the little payload you see there. But it is cleaner in a JavaScript world because JavaScript speaks JavaScript object notation, JSON, natively, right? That's where it came from. So you don't have to do as much work, but let's try this. WSKI action update. Actually, it looks like I have it up there. Let's see if I can just pick that previous one. Yeah. So I'm going to basically update my action. So in the OpenWhisk land, they call these actions as opposed to functions. The same kind of idea. I've just basically mapped it now to JavaScript. Now when I invoke it, I'm going to get JavaScript back. You can see right here. Okay. So I just replaced a Java function with a JavaScript function. Because it is the same input and output, it's all good. So a polyglot architecture is super simple in a function as a service world. You can replace the functions as needed, and it's just a little tight component as long as your input and output is well understood. In this case, JSON in, JSON out. That's kind of the beauty of functions. And you can see my JavaScript one was there. And let's try this trick again. Let's see if we can see it here. There it is. Our invoker gets called again to run that JavaScript function. And again, it comes up and goes away. And you can have a pool of these pods, by the way, kind of already living, and that's basically what's happening here. And it just injects the code, needs it to run, runs it, turns it active. The active flag makes it visible in the console. That's really the trick we've employed here. But you kind of get a chance to see how ephemeral a function is. And let's do this. Let's make the Python version. Okay. And run it one more time. And yeah, don't mind the error there. That's actually tearing down to the previous pod. Gives you the error, but there we go. And you can see there's the Python one we just ran. So the exact same function name, but different implementations behind it. So that's the flexibility you get in event-driven architecture. So this is why you'll go a lot faster with building these kind of applications, is that it basically requires you to decouple the application in this way. Okay? But actually, let's get back into the presentation and show you a few more things before we run out of time. Dun, dun, dun. Okay. All right, let's talk about microservices architecture a little bit more, and we'll talk a little bit about serverless architecture. One thing to understand about microservices is it's fundamentally about distributed computing. You basically have, let's say, the operating system in a JVM or a V8 from Node.js or the CPython runtime. You basically have your language runtime inside your operating system, maybe inside a virtual machine, and that service lives out there and interacts with other services across a network. It's fundamentally distributed. That's the thing. That's what we mean by microservices. You got multiple components in the architecture. And you have to think in terms of the distributed computing fallacies. The network is not reliable. And this is kind of funny. If you're a relatively younger person, especially at, let's say, my children's age, they grew up with an iPhone, if you will, they think the network is always on. They don't remember days when, you had little things dialing in on a modem and then it failed and the bytes failed. You never know what you're going to get. They've never seen a download fail. Can you imagine that? Wow. Okay? But we know better as IT professionals. The packets just don't arrive on time. Okay? Some things are delayed. So the latency is never zero. The bandwidth is never infinite. And so if you actually stretch your application across this network architecture boundary, you have to worry about these kinds of problems. It's just the way it goes. And there's a physics challenge here, too. I've had other people say, but it should work. It's like, well, you can only move so many little photons across that fiber so fast. So there is a speed of light problem. I know it's fast, but it's still a problem. You still limit. So what happens in your network graph of services if a failure occurs? Is it a cascading chain of failures all the way back to your user? Or can you circuit break it and stop it at the point it fails and return some default answer to your user? This is why it's important to understand your network topology of microservices. And so this is where distributed tracing becomes incredibly valuable. And one of the things that's nicely integrated with Istio, as an example, is a distributed tracer called Jaeger that we've integrated. And you can just basically get distributed tracing to show you what this graph looks like right out of the gate. Okay? Now, all the ilities that apply to microservices architecture are things like this. We have to think in terms of our API. We have to think in terms of how do we discover that microservice? How might we invoke it? Are we using some form of RESTful invocation, an RPC style? A nice, and maybe something like a message queue or message passing algorithm. It doesn't really matter. You have to decide what your invocation model is. And you have to think in terms of elasticity and scalability, resilience to that fault tolerance, the possible faults. Make sure you understand your pipeline, how that microservice will be delivered, how it will be authenticated, log it, monitor it, trace it. These are all things you should be thinking about in any kind of microservices architecture. And you should also realize that microservices, we've been thinking about it for a long time. We've been thinking about ways to deploy software faster now since like 1999 when XP became in vogue, right? Extreme programming. How do we actually go from big monolithic teams with big monolithic blobs of software to smaller, more cohesive teams delivering software faster? And so that's really where the microservices agenda came from. We have the Agile Manifesto in February 2001. We have EC2. This is notable because that's when the cloud was born in 2006. DevOps as a term was born in 2009. And we've continually tried to evolve and get faster, better at delivering software. I put Java E6 here because that was a major upgrade to Java E, and I was around for that era. Maybe some of you were also. Netflix, though, came to AWS in 2010. So this is important. Netflix really made a lot of this happen. So we have DropWizard, which started in 2011. Most people forgot about DropWizard at this point, but they were really the first to do this sort of thing. Ribbon came out of the Netflix team, though, in 2012. Basically, Netflix realized that in order to do cloud-native computing with microservices, there's a lot of cool things you had to do, like Ribbon for service discovery and client-side load balancing, as an example, and Hystrix for circuit breaking, and Eureka as their discovery mechanism. And then microservices were formally suggested in ThoughtWorks Radar, March 2012. So notice I'm saying 2012. It was a bit of time ago. And then Docker was born in 2013, Kubernetes shortly thereafter, and you see Spring Boot also. So we've been thinking about these problems for quite some time. Okay? And get my Kubernetes on there. So it's been 3 to 4 years that we've been really thinking through all of this, and you can see Netflix really started a long time ago. Netflix was the king of that universe, and how many people have already used Netflix architecture already? Like you've used Hystrix or Ribbon or anything of that nature? Okay, a few of you. Fantastic, and you might have just used it through a Spring Cloud annotation, right? If you use Spring Boot, it's just an annotation. Fantastic. Now, here's the problem with Netflix architecture. It's Java only, okay? And it puts all that in your code. So your code has to grow accordingly. Your JVM is now running your service with the discovery mechanism, with the load balancer mechanism, with some form of resiliency mechanism, with additional metrics and tracing. All that gets loaded in. This means you have code bloat. Your thing is now bigger than it was. But if you want to, dodge around the fallacies of distributed computing, if you want to get around that network dependency, you would do something like this. So if you come back to this chart and think about these utilities, we've actually addressed a lot of these over time with Kubernetes, with OpenShift. You can kind of see right here, we have Kubernetes, which helped us with service discovery because it has a concept of the service primitive, where the service, the virtual IP address, is decoupled from the actual pods. And you can have 1 pod or 10 pods behind that service name, and all you do is reference the service name. That fundamentally changes the way we write our code and think about how we call from A to B. All you do is reference the service name. That's it. It's like magic, and it works. And Kubernetes ensures that service name maps to the appropriate thing on the other side. And as a developer, you don't have to think about it anymore. As an operations person, you don't think about it. And invocation models are also pretty much in there. If you want to support HTTP or any kind of normal protocol that you want, AMQP kind of just works, okay? Elasticity, it keeps all these things up and running. You have your concept of the replicas. And of course, OpenShift adjusts this by adding new capabilities on top. I mentioned earlier that OpenShift gives you additional enterprise capabilities like pipeline integration with Jenkins, additional logging, additional monitoring. And now we have this thing called Istio, okay? So Istio, by the way, stands for sail. It's another Greek nautical term. Kubernetes, of course, is a ship's pilot. The ship's pilot comes because if you think of a Docker icon, it has a little whale that's a container ship. And Kubernetes is there to manage all your container ships. And then we have a sail that you put on your ship. So you'll see a lot of that. And Istio is implementation of a service mesh. It is infrastructure that is slightly above the layer that Kubernetes is at, which is more like the network level infrastructure. And its job is to try to give you a topology and a framework for handling all those microservices and how they talk to each other. If you have 25 of these or 200 of these, it gets to be a challenge. How many people here, we mentioned earlier, most people here have done some microservices. How many people here have greater than 200 microservices in their average system? Okay, so just a few of you. How many people have at least 10 microservices? Okay, so the numbers are still relatively small in terms of microservices architecture. For the average organization I've run into, they have like 2 microservices. Well, that's not really 2 microservices, okay? That's like 2 baby monolithic applications. It's not... it gets interesting when you get into the hundreds of microservices, and that's why Netflix did what they did, okay? You got to, once you're trying to manage 100 of these things that are all dependent on each other, it gets interesting really fast. So the Istio, though, really helps you from this perspective. You can see how Istio augments our chart here. Istio augments the discovery. It helps with resilience. It takes the circuit breaker out of your code, puts it in the infrastructure. Authentication built right into the infrastructure. Additional monitoring, additional tracing. So Istio is highly complementary of what you see in Kubernetes and OpenShift, okay? This is what we looked at before Istio. This is what it looks like after Istio. It takes that stuff that was otherwise in your service and puts it in this little sidecar container. So one thing a lot of people probably didn't realize is your Kubernetes pod could have more than one container in it. I know we never put more than one container in it. We've had this thing for years now. We stick one container in, one container in. That's what we've always been doing. But it could always have more than one. And the cool thing about that is the container shares the same lifecycle at that pod level. It also shares the same IP address, and it shares the same memory and storage space. And because it shares the same IP address, though, it can intercept all traffic in and out. That's what this thing's going to do. The sidecar basically says it hijacks all traffic in and out, and that's how it applies its magic. So you got to think in terms of Istio being that sidecar container. And then it has certain capabilities. The sidecar, by the way, is Envoy. It came from the Lyft team. They run it at scale in production already. It's written in C++. It's a layer 7 reverse proxy. Incredibly lightweight and small, and that's why they use it inside as a sidecar container. You can do things with Nginx and Linkerd and other technologies, but they don't tend to run as sidecar containers as much because they're a little bit bigger, and they're also a little bit hard to deal with at times. You tend to run them as node proxies, right? Maybe living on the node itself, proxying all the traffic in and out. These guys literally run inside that pod, okay? And adhere to the pod lifecycle, which is really nice. And it's really nice. So you can actually do some really cool things with the service mesh technology. For one, it's code independent. If you want to run Python and Node.js and Ruby and Go and Java, all these features apply, unlike the Netflix library, which is Java only. So in the modern architecture going forward, you probably will have some Node.js running beside that Java code, running beside that C# Node, .NET Core, or running beside that Go technology at this point in the average enterprise. You can do things like really intelligent routing. So by default, Kubernetes OpenShift has really basic routing inside the logic. Basically, you can have if you have 2 pods, it's 50-50. If you have 3 pods, it's 33, 33, 34. If you have 4 pods, it's 25, 25, 25. That's the logic you get out of Kubernetes and OpenShift by default. With this, you can say, I want 2%. 2 pods, 2% going one way, 98% going the other, because it allows you to actually do that at that level. It's really nice from that perspective. You also can inject chaos engineering into your architecture. You can basically put network delays directly into the components. You can also just send network errors through the wire. And this is really awesome, because then you can see how your software behaves should somebody be a bad actor or just write bad code. Okay? Now, you might be thinking, why would you ever write bad code or cause injury to yourself? I actually was talking to a senior manager who had a bunch of developers recently, and he was telling me, I really love OpenShift, I really love Kubernetes. I was like, why? I was thinking, okay, there's a good case study here. Let me talk to this guy. And he said, well, I got some really bad programmers. It's like, okay. He goes, you know how if you write Java applications, or, he said mostly Java, my Java programmers, they write a lot of bad code. It tends to overuse memory. They probably overuse a static keyword in Java. And they just kind of blow out the heap. And, of course, it dies. The good news is Kubernetes restarts it automatically. And that was his whole solution for dealing with that. It's like, OK, sounds like a great point to me. But how about injecting chaos directly into your architecture to see what happens, right? See how things fail. Okay, this is what the architecture looks like. You'll see it basically has your pod, your container running in that pod, your JVM, let's say, running your service A or B or C, and the Envoy sidecar is sitting right there with it. And then it has this control plane. One, you'll see the Istio pilot, the Istio mixer, and Istio CA, the certificate authority. So you can do mutual TLS across these pods, and you have this concept of being able to change route rules, and also adding things like telemetry capture, tracing capture, monitoring capture. So that's what this is here for. It actually adds a ton of value right away, but you are running these additional 3 pods that you see here, as an example. So you have to think in terms of this is additional things that your operation team has to worry about. But from a development standpoint, it offloads a ton of things you don't have to worry about anymore. I don't have to think in terms of circuit breakers or service discovery or service resiliency. The infrastructure takes care of that for me. Very powerful technology, and like I said, I highly recommend the lab that's tomorrow. As I mentioned earlier, this is the old Kubernetes or OpenShift model. It's 50-50 if you have 2 pods. It's 25, 25, 25, or 25 if you have 4 pods. Very simple routing logic. In the case of Istio, you can say how much percentage of the traffic goes to this other pod. If you're doing a canary deployment, this matters a lot. And if you're not doing canary deployments, I'd highly encourage you to think about canary deployments. Blue-green, that's like old 80s technology. Okay? Red, black, blue-green. But a canary deployment, you are rolling into production almost instantaneously. The pipeline executes, it does the build, you run all your unit tests, you run all your integration tests, because you guys know you have awesome integration tests, automated, right? You don't have any QA effort whatsoever. All the integration tests run. You pop it actually into production and see if it just dies. Because that's the nature of the canary in the coal mine. You guys heard that story before? The miners used to take, the coal miners used to take a little bird in a cage down in the coal mine, and then if the bird offered 2 features. One, it would sing and entertain them, a little cute little bird, but also the little bird was a little more sensitive to noxious gases down in that coal mine. And if the bird fell off its perch and died, you need to get the hell out of the coal mine. Same idea applies here. You float that thing out to production, maybe send it a little bit of traffic, see how it behaves. Is it eating all its memory, chewing up all its CPU, just dying and the JVM is barfing? Get it back out of production. That way you go a little bit faster. Okay? I won't have time to do this demo, but this link will take you through all of the content you could possibly stand in this topic. And as I mentioned, there is a book that you can come pick up in the booth, right? Oh, actually, he left already. But I think we do have that book in the booth also. Okay, what else we got here? Oh, let's talk about serverless briefly. So we showed you the short history of microservices. This is a short history of serverless. So notice also, it started back in 2012 as well. And actually, it wasn't coined by Microsoft, the term. It was actually coined by a little team that came out of Iron.io. I'm not sure if you ever heard of them before, but they basically run a message broker in the sky. They have message broker as a service, and they talked about this concept of the serverless or backend as a service, is around the same time frame, where instead of actually having an application that has to deal with its messaging, deal with its database, deal with its security, you now have all those as a service. So that's why it makes it serverless, because you just ignore it and you just call their API. But you can see what's happened here. A lot has happened in the space. Right here, where Google came out in 2016, Azure came out, OpenWhisk came out. So IBM, Microsoft, and Google all kind of came out in the same time window there. And when IBM came out, they also open sourced it. So they did IBM Cloud Function and open sourced it within a few days of that. That's why we jumped on the OpenWhisk train, and that's the group that we're focusing on. Okay, so Red Hat is focused on OpenWhisk. You can kind of see ThoughtWorks when they got involved, Oracle Functions, Oracle FN Project. And I think Oracle Functions is dead already. FN Projects replace it. So you're going to have to watch for that. There's going to be a lot of change in the industry over time. But this is where we are in the serverless architecture, and I kind of showed you a little demonstration of what that looks like. Okay? I think I'm almost done here. Oh, how many people here are Spring Boot people at this point, using Spring on OpenShift? So I'd highly encourage you to check out these links and resources. We have a Spring Boot reference architecture, and I'd love your feedback on it. You can kind of say, oh, that's how we do it, or no, we don't do it that way. I'd love to know more about that. We have these great Spring Boot demos that my team specifically worked on, and actually the gentleman will be down the booth. I'll be running down to see him in a second. Like the popular movie store one there is super cool. What we've done is we've integrated the JBoss data grid, the InfiniSpan technology, and what we show you is using a Kubernetes readiness probe and liveness probe, we actually show you how we do rolling updates to a stateful application in real time. So basically it's a Spring Boot application running as pods inside of OpenShift with a readiness probe and a liveness probe that basically says, as soon as you try to upgrade me, I need to first make sure my state is replicated off to the other pod, my peers, and then I can go down. And so you can actually do a rolling upgrade across the distributed architecture, fully statefully done. So what we do is we have a shopping cart. You put stuff in your shopping cart, then you issue a code change and watch it roll out. Okay? Really fun presentation and nice demonstration there. You also see we've also migrated a Spring Boot application from Cloud Foundry. So the gentleman asked about Cloud Foundry earlier. You know, if you need a migration, that bit.ly green cloud demo there will help you think through the migration. And then, of course, you can do all kinds of cool things like integrate Camel, Apache Camel, or Fuse technology inside a Spring Boot application as well. So I make this point because Spring Boot, as you saw by the number of hands, is very, very popular when it comes to JVM-based microservices architecture.